Okay, we have discussed about array. Okay, one of the purpose of having array is that you want to process many values at the same time. Yeah, you want to process many values at the same time, and if let's say you have many values at the same time, it is not suitable for you to declare so many variables. Okay, so the way we tackle this is by having array. Array is basically a data structure that you can create, which can hold many values at the same time. Yeah. So we have discussed on how you can create array. That is important. Okay, the way you declare an array. Let's just show you some example. For suppose I'm creating an array of size 5. So you need to basically declare the size of the array. This is a must. Yeah. You cannot just leave it blank. This is how you declare an array. And then normally we are going to use for loop in order to process your array, right? So we have discussed this is the normal way of you to create for loops. Okay, and suppose I'm going to display the content of my array. So I can just simply write over here, cout AR, and then my index will be I. Okay, my index will be I. This is how you can actually control how to access the element of the array. Yeah. So since I'm not declaring any value inside my array, so what happens is that I'm going to have sorry. Okay, I'm going to have some kind of random values lah, right? Random values. So you can actually initialize the content of your array by having another for loops. Okay, and over here you can just simply assign everything to equals to 0, right? So by having this, then when you display your array, you are going to have all initialized to 0, right? So this is how you declare. Then you are going to always use for loops. And we also have discussed on another kind of for loop in which we call as range-based for loop. Yeah, range-based for loop. So for example, if let's say I want to replace this with a range-based for loop. Okay, you just need to remember the syntax. Yeah. Okay, so the syntax is quite similar to for loops. Over here, you just create a variable. I don't know, maybe a val. Okay, then separated by semicolon. Then this on the right side of the semicolon, you just put ARR. Okay, and then over here, if let's say you run something and then you did not initialize things, so it's going to be some random values lah, of course. Yeah. So suppose you are using this as your for loops. Okay, remember if let's say you are going to change the content of the array by using range-based for loops, you need to pass this as reference. Okay, and then over here you just assign everything to 0. Okay, so by having this, all elements will be initialized to 0. You just need to remember that if let's say you are going to modify the array, so this value need to be declared as reference. If you don't declare this as reference, then you are not going to be able to change the value of the array. Yeah. Okay. So this is range-based loop. Okay. Now let's move on. Yeah. We also have seen how you can actually pass array to another function. Yeah. How do you pass array to another function? So suppose I'm going to create a function named display. Okay. And I'm going to pass the array here to another function. So I'm just need to pass array. And normally when you pass an array, you need to also pass the size of the array, right? So that's quite important as well, because normally you are going to use for loop inside the function, and then you need to know what is the size. So rather than passing 5 over here, it is good if you can create a constant. Suppose size equals to 5. Okay, so by having this, you can just replace everything, the size of the array to size, and this one, when you pass, you can pass size. Okay, and this one can also be size. All right, so this is how you do function call. So as usual, when you create a function, make sure you follow the 3-step. Okay, this is just function call. You need to do the function definition. Okay, remember, function definition is something like this. So you need to specify what is the output, what would be the input over here. I mean the parameter. So over here, the parameter is supposed to be an array as well. Okay, so what you can do is you can just simply copy this lah. It will be easier. Yeah. So just copy this and then put it here as your parameter. And then you need to leave this as blank like this. All right. And then this will be your size lah. Yeah. So maybe I can put here small letter. It's possible. All right. So in order to display, I can just copy this, put it here. Okay. All right. So it will be something like this. Then don't forget to do function declaration before your main. Okay. This is a normal practice. And put semicolon at the end. Yeah. All right. So let's say I run this. Hopefully no problem. Okay. All right. This is supposed to be size because we are looking at this. Okay. So the reason why you have very random is because this one we did not put as reference. So when we run, so this one is going to be 0. Okay. And then we pass the array to display function, which is this one. Okay. And we also pass the size. Okay. The reason why we pass the size because we want to create a for loops over here. And this size, when you pass it from main function, it will refer to the size from the main function. Yeah. Is it clear? Okay. Any questions so far? All right. Now this is one-dimensional array. Yeah. One-dimensional array. Let's move on to our what happens if, let's say, you want to create an array of two dimension. Yeah. So this is what we are going to continue. So when we talk about 2 dimension, okay, you need to imagine the array which is quite similar to the matrix structure. Okay, matrix structure whereby you have column and rows. Okay, suppose this is your array. So this will be what? Column or row? This is column. Okay, how many column that you have? 4. Okay, so the size of your column is 4, and this will be your row. Okay. So in previous assignment, we used to ask students to create chess game. All right. So if that is your assignment, then you need to view the board as an array of rows and columns. Yeah, 2D array. All right. So suppose this is the array that you are going to create. So how are you going to declare? Right. So this is what we are going to learn today. So 2D is quite similar to a table in a spreadsheet. I think you have done or you have created some table, okay, in your Excel sheet, for example. So what you need to do if you want to create 2D array, you need to specify rows and columns. Okay, so since it is a size, so you declare them as constant. Yeah. So rows 4, columns 3. So that means the structure will be something like this. You have only 3 columns, okay, and then 4 rows. Yeah. And the way you declare should be something like this. Your first square bracket should contain the size of the row. Your second square bracket will be the size of the column. So it always start with the rows and then columns. Then, of course, if let's say you extend it to maybe 3D, then it will be other things. You are going to add another one over here, which will be the Z. Okay, this one. Okay. If let's say you are dealing with machine learning later on yeah, various dimension, so you are going to come across more than 2D. Yeah. So this is something fundamental. The moment we extend array to 2D, we are actually adding square bracket to the left. Yeah, to the left. As we have higher dimensions, so we are going to add more to the left, right? Okay. So suppose rows is equal to 4 and column is equal to 3. So you have rows 4, columns 3. Okay. How do you access the location of each element? How do you access? So normally you are going to access based on row first, okay, and then followed by column. So suppose 0, 0. So that means because you know that index will always start from 0. Okay, so this is 0, this is 1, this is 2, and this is 3. Okay, and this is 0. Sorry. Okay, this is 1, and this is 2. Okay, so suppose I want to access this. I want to maybe okay, suppose I want to assign here a value of 10. So what I'm going to do is I'm just write exam followed by the row number, which is 2. Okay, and then followed by the column number, which is 1. Yeah. So in this case, I'm assigning exam 22. Exam 22 is here. So I'm assigning 86 in this position. All right. Okay. So hopefully by now you know how to declare. This is how to declare. And this is how to access your array location. Okay. Example of program. This is a program to demonstrate a 2D array. So you have division and quarter. This is the row, this is column. So effectively you have 3 rows and 4 columns. Okay, so total sale equal to 0. Div, okay, this program will calculate the total sale of all the company's division, enter the following sale information. All right, so okay, now for 1 dimension, you only need 1 for loop. If you have 2 dimension, you are going to have 2 for loops, but one for loop will be inside another for loops. Yeah. So the outer for loop, this is outer, this is inner. Yeah. Now the outer for loop will normally cater for rows. Okay, rows, and the inner will be catering the columns. You need to remember this, otherwise it will be jumbled up lah. Okay, because this one would be your row. As you can see, div is row, right? And then quarter is your column. Yeah. Okay, similarly, when you want to display, or this is to add all elements, you start with the row first, and then the inner follow will be the column. All right. This is how people normally do it. Of course, you can do other ways. Okay. If you put the inner loop to be outer loop, then you need to switch these numbers lah. Okay, that's fine. All right. So this is the output. Okay. All right. Now, how to initialize your 2D array? It's quite similar to how you initialize 1D array. You are going to have comma. All right. So for each comma, you are going to settle for one row. Okay. The first row is here. Okay. You have another bracket, and then you cater for the second row for another bracket. Yeah. So this is first row. This is second row, separated by comma. Right. So between the column itself, you also have another comma. Yeah. All right. So array element without initial value will be set to 0 or null. Okay, depending on situation. Okay, next, how do you pass 2D array? Okay, just now you have seen how you pass your 1D array, right? As to another function. Okay, if you pass 1D array, when you do function call, you just pass the array name and also the size. Yeah, but now you are having, okay, then your parameter, this is the way you declare, and this will be the size. Now suppose you are passing to the array, right? When you pass to the array, the way you pass is quite similar. Yeah. When you do function call, you are going to just pass the array name. Okay, you put down here, and also the size. Now the size over here would refer to your rows. This one will be refer to your rows. So for example, this is I think over here, I think declaration of exam would be int exams, and then you have maybe some values. This is supposed to be row. I don't know, maybe 5, and you have calls. Okay. Then when you pass, you are going to pass just the name of the array. But when you do prototype, sorry, before prototype, you might want to see the function definition over here. Get exam. So okay, this is the part that you need to be careful. Yeah. For 1D, this one is supposed to be just empty. But for 2D, you have your rows will be empty. Your column, you're going to have some values inside here. Yeah. And this will be the size of your rows. Okay. So that's why whenever you pass an array, there's always one more parameter need to be added together with the function call. That parameter will be the size. The size. Okay. If 1D, then it will be the size of the array. If 2D, this will be the size of your rows. If 3D, then this will be the size of your depth. Yeah. Let's have a look at this example. Yeah. So this is function definition, show array. Since this is 2D, so you have the first one is empty. Second one has size. Okay, and then the rest is rows. So if let's say you are passing a 3D, I think. So your 3D will be int array. And then you are going to also have empty bracket over here. And this will be your maybe rows. And you are going to have columns, something like this. And then you are going to have another parameter just for the depth. Yeah, this is for 3D. So, and then if let's say you have 4D, 10D, so on and so forth, so you're going to have a long sequence of square brackets. Yeah. Okay. So this is just the for loop because this is 2D, so you have the outer loop and also the inner loop. Okay. So how show array is called? Function call is very simple. You just need to pass two things. Number one is the array, and then number two is the size. For 2D, the size will be rows. For 3D, the size will be depth. For 1D, the size will be the array length. Yeah. So function call should not be a problem. The way that you the things that you need to focus on might be how do you write the function definition, something like this. This is function definition. Yeah. This is how you declare and initialize array. So this is 5 by 5. So this is how you initialize. Yeah. This is how you sum all the elements in 2D. Since it's 2D, you need to have two for loops. Okay. And then you can simply display. Okay. Maybe I can just quickly show to you. Yeah. Array of 2-dimensional. So I can just put here maybe column equals to 3. And then I'm going to have another one column, sorry, row equals to 2. Yeah. So then I'm always having here row and column. Okay. All right. So range-based loop. So I need to show to you. I think better for me to just show to you double for loop. Okay, so that we are consistent with the textbook. Okay. So normally I will always use I and J, right? Or it will be easier for you if you put R Okay, row less than row, then row plus plus. Okay. And then let's say I want to initialize everything. So I can just write ARR. Sorry, I need to have another for loops, inner loop. Okay, so inside here, I'm just, okay, I need to change this to column. And then column is less than the big column. Okay, so this is one way. Okay, and then over here, I can just write ARR. I will start with column. And sorry, this one's supposed to be row. Okay, always start with row and then end with column. Then I'm assigning everything to 0. So for display, okay, display is quite simple. I just call array and then I pass what? Row or column? Row. So I pass row over here. All right. Then display array here. So this is supposed to be column, right? And then this is maybe row. Okay. So I can just copy this and put it here. Okay, I need to change this. I is equal to 0. I less than let's check. Yeah. Okay. So this is supposed to be col, and then this is I. So I will always start this with J. Okay. The first index will be coming from your outer loop, and then this is I. Okay. So you need to have a bit of practice. In order to familiarize yourself with this 2D. Yeah. In this case, C out AR J. Okay. And I'm going to have this separated by space. And then for each of this, I'm going to have C out and line. So I'm going to have one line, and then I'm going to increase. This is for the next iteration, which is the same, the next row. So if I run, hopefully there's no problem. Let me just check line number 12, row 0, row less than row. Yeah, this one. It's not supposed to be here. Okay, and then I guess this is also. Okay, so let me just run. What else? Function call. ARR. Cannot convert integer to integer. Cannot convert integer 3. Display. Okay, display. We pass this. There should not a problem. Should not be a problem. I think, yeah, this one. The header is not okay. was not declared. The column. Okay, I think you need to have this maybe as maybe this one you need to pass 3, I think. Yeah. Number 5. All is not. So sometimes this one, sometimes column we put as global variable. Sometimes convert. This is 3. This is supposed to be 5. This is 3. So need to be consistent. So let's put here 3. Okay. So when you try to display your multi-dimensional array, all right, you need to basically visualize first how you're going to display, because multi-dimensional array, of course, the one you're going to display, you need to display separated by spaces in rows and columns as well. So this is what you normally do. You're going to have 2 for loops. This would be for your rows, okay, for each rows. That's why for each row we have space, okay. So we have space here, we have space here, okay. The moment you finish the inner loop, so basically you finish the first row. That's why after first row, we want to add a line so that we move to the second row, okay. So that the next iteration, this would be starting from a new line, yeah, okay. All right, so this is just demo for you. Hopefully, you should be able by now write codes based on multi-dimensional array, especially 2D. So I think for programming fundamentals, we are not going to ask you more than 2D, especially in your midterm test. If you want to prepare, you can just prepare up to 2D. Yeah. Otherwise, it will be very messy. You are having 3 for loops, and I don't think it will be appropriate. Okay, unless it will be a assignment. Yeah. Okay. So basically, we have completed what is necessary for you to understand array. We have discussed the first 1D array. How do you declare? How do you initialize? How do you access? We also have discussed on 2D array. How do you declare? How do you initialize? How do you pass as a function? Sorry, as an argument to another function. Yeah. This is just for your information. I think example for 3 dimension. Okay, this is 3 dimension. If you're going to have 4 dimension, is this. Later on, you are going to learn machine learning. For those who are taking data science, you might have many features. Yeah, many features. The more features that you have, you're going to have more dimension. Okay, so that's why when you process your data, when you train your data, if you have many features, then a lot of data need to be processed. But everything will be based on array. Yeah. Okay, vector. Last semester, the midterm test was on vector. Yeah. So definitely there will be question either on array or vector. So make sure you prepare for this. What is vector? Okay, why vector is introduced in C++? Now, if you can still remember, when you declare an array like this, it is important for you to declare the size, right? You cannot have an empty bracket. Okay, that is the nature of array. You need to declare the size when you declare an array. All right. The problem with this is that sometimes you are not sure how many elements that you are going to use. For example, if let's say you want to create an array of students, okay, maybe array of students who will be joining programming fundamentals. Maybe early in the semester, since we have 3 sections, so my guess will be 160 plus 160 plus 160, in which in total we have 480 students. So if I were to be the programmer, I'm going to just create an array students. The size is 480, right? Now the problem here is that I need to make sure the system is ready before the student registration. And then what happened was when students start to register, the total number of students is suddenly dropped to 300, for example. So there is a waste of 180 location unused. Yeah. So this is the problem with array. You need to specify the size beforehand, and then what happens is that if let's say the size is less, then there'll be a waste of memory. If the size is higher, then you need to change many things. Yeah. So that's why vector comes in. Vector is some sort of array, but the array, there's no need for you to specify what will be the size beforehand, before you use it. So it is an efficient kind of array, right? So this is what we're going to learn. how you can declare a vector, how do you initialize vector, how do you access vector. Okay, so in short, vector is basically array of variable size. Yeah. Okay. You are going to learn more on STL because vector is basically data type defined in STL standard template library. It can hold values of any type. The size is varied. You can have as low as 1, okay, the size of the vector, or 100, for example, or maybe thousands. Yeah. So this is the way you declare vector. You don't start with data type. Okay. So normally when you create an array, you have data type first, and then the name of the array, and then followed by the size. But for vector, you write vector first, and then you're going to have this bracket, and this is where you specify what is the type that the vector will hold, right? So in this case, okay, we know that this vector is for integer, yeah, and this is the name of the vector, scores, yeah. How to access the element, because this is quite similar to array, but it is a variable size, so you can still access using bracket, similar like you access using array, yeah. And there's no need for you to specify what is the size of the score over here, okay, no need. C++ will add space as needed. Okay, so if you have more students, for example, so it will add more space. If it is less students, so it will reduce less. Okay. This is how you declare vector. Make sure you include this as your preprocessor directive. Declare a vector, as I mentioned. The type will be inside this bracket, and this is just the name. Okay. You can, this is optional. You can declare the size if you want. If you declare the size, then it will, the way you treat it is quite similar to array, yeah, the size. This one is optional. This is how you initialize. If let's say you want to initialize to zeros, you can just simply put this as your second parameter. All right, it's quite easy compared to when you want to initialize array to 0. Okay. Then if let's say you want to initialize, you want to create another vector, and that vector is having the same size and content of another vector, so it's something like this. So this is quite similar to when you write finals is equal to scores. Yeah. All right. So it's quite convenient having vector. So this is how you initialize if you want to initialize. Okay, since there is no way for you to know the size, right? Because the size keep increasing. So how do you actually add new element to vector? You can use pushback. This is to add new element to the scores. Okay. And you can call size in order to know the size of the vector, right? So for example, let's say this is this is scores. Yeah. Let's say this is scores, and scores is initialized with these 4 values. Now, graphically, I'm creating an array. Okay, I'm going to have 10, 20, 30, 40. All right. So this is 10. This is 20. Okay, and this is 30, and this is 40. Okay. So the index itself, why 40 is missing? Just put here. Okay. Now, normally if you deal with array, so if you want to add one more over here, of course your array is maybe you need to declare bigger size. So this is your index 0. Sorry, this. Okay, this is your index 0, and this is your index 1. And this is index 2, and this is index 3. Okay. So if let's say you want to add new element over here, what you need to do is you need to write score what? 0, 1, 2, 3, 4, right? 4 equals to, maybe if you want to assign 75. So you need to write score 4 equal to 75. So what happened here is that you are going to have over here 75. Okay. That is if you want to deal with as an array. But for vector, since the size is not determine beforehand. So the way you add things at the back of the array is by calling pushback. Okay, so you call pushback, put 75. So C++ will know that, okay, this 75 is going to be added to the end of the array, right? So this is what happened. So you need to keep track on what is the current size of your vector. This is something that you will do normally because you don't have an idea of what is the size of your vector because you don't put the size beforehand. But for array, of course, you can use for loops. It to be settled, okay, because you know the size. So you need to keep on calling this function before your during your for loops in order to just check, oh, okay, what is the size of my vector now? Because sometimes you add, sometimes you delete your array, so you need to keep on asking. So the way to asking to ask the size of your vector, because your vector keeps on changing in size, is by calling scores.size. This is member function. It's a function call, but it's a member function. Why member function? Later on, when you learn object-oriented programming, you are going to know more. Okay, similar like when you open a file, you have dot open, right, instead of just open. So it's a member function. Don't worry at this point. So if you want to remove elements, normally when we add, we are going to add towards the end of the array. If let's say you want to remove the end of the array, you can use popback. Okay, popback. How many of you have come across stack? Have you heard about stack? First in, first out, or last in, first out, you know? In data structure, later on, you are going to learn about queue, how to create data structure queue, how to create stack, okay, last in, first out. So you are going to use vector a lot, yeah? So pop, okay, you have push over here, and you have pop. It's quite similar to when you have stack. If let's say you fold clothes, when you fold clothes, you're going to put the last clothes on top, right? Okay, so the last addition will be put on top, which is here. Okay, so in programming, you can use pushback. The moment you use pushback, this will be the last element that you add to your array lah. So this is supposed to be your 0, and this will be your final elements. Okay, so in vector, you can remove the last element, okay, the last element of an array or vector by calling popback. Okay, so there's no need for you to actually specify, okay, what is the my size, my array size? Then you want to remove the last element over here, so it's quite cumbersome. Yeah. So in vector, there's already a function that you can use. If you want to add one more data at the end of the array, just call pushback. And if you want to remove the last data, you can just call popback, right? If you want to remove all content of the vector, okay, because maybe you don't no longer use the array, you want to remove everything, so you just call clear, right? Okay. Let's have a look at an example. Yeah, how you can use vector in the program. First of all, don't forget to add this library. Okay, let me just check if I can copy this. Cannot. Okay, that's fine. So you have vector. This is how you initialize your vector. The name of the vector is numbers. So we initialize with 5 elements. So this, you are using range-based loop to basically display everything. Okay, so we're going to get this. All right, so this is some of the member function that you can use. Capacity, reverse, resize, and swap. Swap is to exchange content between 2 vectors. Resize is to resize vectors. Reverse is to reverse the order of the element in the vector. Okay, suppose you have 10, 20, 30, 40, 50, and then you want to reverse this. Okay, you want to put 50 here, and then 10 here, and then 40 here, 20 here, and 30 you maintain. Okay, so rather than you write your program yourself, might as well you just create a vector and then call reverse function. You are going to settle it easy. Okay, so in order for you to know what is the values at certain position I, so you can just see out dot add function. Yeah. Okay, any question? We are going to do more practical in the lab, I think, for vector. Yeah. Okay, if no question, then we take 5 minutes break. Then we are going to continue with searching and sorting array. Okay, let's continue. All right, so the next slide over here is on application of array. Okay, you have learned array in 1D, array 2D, and then we also have discussed about vector. Yeah, vector is basically a variable size of array. Now, one of the application of array is you can use array to do searching. Okay, because suppose you have array of 100 values, and then you want to search certain value inside the array, whether the value is inside the array or not. Another use case, if let's say I want to search a name of a student inside a list of array. So there must be an algorithm for you that you can write on how you can actually do searching. Yeah. So this is something that we are going to learn the algorithm. Basically, you need to understand the algorithm. Yeah. So for searching, we are going to cover two algorithms. Number one is linear search. Okay. For searching, linear search. This is for searching. We're going to cover today. And then there's another type of searching which is faster. We call it as binary search. Okay, so linear search is slower, binary search is faster. So as a programmer, it is best if you can write a program in which things can be completed in a faster manner. Yeah. So and then sort. You know what is sort, right? Sort means you try to arrange your array in maybe alphabetical order, right? Or maybe from 0 to 9. Okay, so this is what sorting means. So sometimes you have array, you have many values, you want to sort it. All right. So we are going to also look into sorting algorithm. There are many kind of sorting algorithm if you try to search. Yeah. There's a comparison based sorting in which you have bubble sort, okay, and then you have selection sort. Sorry, okay, selection sort, insertion sort, merge sort, quick sort, heap sort. Right. So later on, when you learn computational method, you are going to check on the complexity of your calculation. Why people is creating many kind of sorting algorithm, because we want to find which one is the most efficient one. Because especially in machine learning, if let's say your data is 1,000 or 100,000, if you want to sort those, it will take ages. Yeah. Of course, computing power will become better and better, but then that is a different. If let's say you try to solve things, you require 10 minutes versus 1 minute. Of course, people will want to have a more efficient algorithm. So that's why you have many kind of sort. But for programming fundamental syllabus, we are going to just focus on these two sort. Sorting algorithm. Number one is bubble and number two is selection. Okay. What is important is you need to know how the algorithm works. That's important. Writing program for sorting now has become easier. You can just call function bubble sort, function selection sort. I think you can get the function quite easily. But what is important is how the data is being moved around based on bubble sort. Okay, how selection sort works, right? Okay, don't worry about time complexity. As you can see over here, it is n square or bubble sort selection. This is what we call as O notation. Later on, you are going to learn this in computational method. This is n square for insertion sort. You can see log. So the moment you have complexity equals to log, that means you have more efficient algorithm. Yeah. How to calculate this complexity, you are going to learn later. I'm not going to cover it in this programming fundamental. Okay, so there are these 4 things that you need to know. So I'm going to just focus on these 4 things. Sorting algorithm, we only cover bubble sort and selection sort. Okay. All right, let's continue with linear search first and binary search. Okay, I'm trying to cover these 2, and then if we still have time, then we will cover the sorting. Otherwise, we will cover the sorting during our online replacement. Okay, let's move on. Now, searching. I'm going to show to you this YouTube video. Okay, how can you do linear search, right? So let's have a look at this. So in this case, searching value is 3. We want to search 3, whether 3 is inside the array or not. So linear search means it will start from the beginning until the value is found. Okay, in this case, okay, value found, then it will stop searching. All right. So the advantage of linear search is that if, let's say, 3 is here, then it becomes very fast, right? If 3 is here, then okay, the moment it found 3, then stop. Okay, so your algorithm will be very fast. But your algorithm will be very slow if, let's say, 3 is here, right? Because it will start from 0 and then it has to traverse until the end. So this is the worst case scenario. The best case scenario, if let's say 3 is here, the worst case scenario is if 3 is at the back of the array, right? In which you need to traverse from the first until the end. Imagine if, let's say, you have 200,000 size of array. So it will be quite taking some time. Okay, this is linear search, all right? Let's have a look at second type of search, in which this is more, I would say, efficient. We call it as binary search. Yeah, binary search. Yeah, this is binary search. So suppose the value to search is 5. We want to check whether 5 is it inside the array or not. Okay, so let's have a look. Okay, only 3 steps. Okay, what happened in binary search? Yeah? Okay, the algorithm is something like this. For linear search, you are going to search from the first location until the end. Okay, until you found, until you find the value that you want to search, and then stop the for loops. Okay, binary search. First, you are going to divide your array into 3. Okay. First is you specify the starting position, of course, and you specify the last position, of course, in your array, and you are going to find what is the middle position. Okay, one prerequisite for binary search is that you need to make sure your array is sorted. Okay, you must make sure your array is sorted. That is the prerequisite of binary search. If your array is not sorted, then you cannot use binary search. Okay, so you must use other type of search, maybe linear search, so on and so forth. Okay, so if you can see from here, this is a sorted array. You have the first element over here is the smallest. The n element over here is the largest value. All right. So in order to start your binary search, you specify what is the first element, the first location, and then the last location. And you need to find what is the middle location of your array. So in this case, 0 plus 7 is, how to find the middle one? You can find by adding 0 with 7, then you have 7. 7 divided by 2. Okay, 7 divided by 2 is 3.5, right? But instead of taking 3.5, you just take the integer, okay, which is 3. So in this case, we just evaluate this middle. Because why it is called binary? Because you divide it into 2 sections, the left section and the right section of the middle value or middle location. Yeah, so that's why it is called binary. So suppose you have already identified what is the middle location, so you check 4. Okay, so in this case, this is 4, but you want to search 5, right? So if 4 is less than 5, then you discard this one, because whatever that is on the left of 4 is definitely number which is less than 4, because it's already sorted, right? So you want to focus yourself on finding the right side of the array. That's why we call it as binary, because for each iteration, we divide the array into half, we check the middle value. If the middle value is less than search value, then okay, we already know half of the array on the left side is already irrelevant. Okay, irrelevant, not relevant. So we focus on the right side of the array. So, and then, okay, 4 is less than 5. So what happened here is that after you have identified, okay, 4 is less than 5, so you want to focus yourself on the higher half of the array. So what you can do is, now you assign your low here and your high here, all right? Your low no longer starting from 0, because you want to focus on the second half of the array. So your low is here and then your high is here. So you are going to calculate what is the middle between low and high. So what you can do is 4 plus 7, which is 11. 11 divided by 2, which is what? 5.5, right? But we are going to just take 5. So your middle now becomes 5. Okay. So we check. What is the value of at position 5? 6. 6, is it greater than or less than 5? It is greater. So since it is greater, then definitely your search value might be on the left side of the section, which is here. Okay. So we remove this part. So your high now becomes here, right? And then your middle is here. So now you already found your search value. So as you can see over here, it only require 3 iteration. Okay, so let's try to go back. Okay, this is first iteration. Check. Okay, this is first iteration. Then we change the low. Again, this is second check, second iteration. This is third check, third iteration. So your for loop only round 3 times, and then you already found the search. Quite fast. But if you use linear search, you're going to check. Okay, number 1 check, no. Number 2 check. Number 3 check. Number 4 check. Number 5. Then you need to have 5 iteration. Yeah. Okay. So this is a binary search. Okay, so we still have time. Let me just finish the sort. Bubble sort. Okay, I did mention sort means you want to sort your array according to ascending order or descending order. So normally we pull it as ascending order. Okay, let's leave this this coding first. Okay, let's try to understand the concept first. Now, bubble sort means you check 2 by 2. You check 2, and then you check 2. Okay, let's have a look at this. Okay, you check first. If it is not in order, so you exchange between the 2. Okay, this is first pass, and then second pass, check again, check again. Okay, if it is not in order, so you change. So there will be many passes until you no longer need to exchange. Then it will stop, right? So let me just, okay, first we check between 6 and 9. Okay, this is already in order. So we move on to the second one. Okay, this is not in order. So we exchange. Okay, and then check the one, this one is not in order. So we change. Okay, and then this one not in order as well. So we change. Okay, and then check this one, not in order also. So we exchange. This one not in order also. So we exchange. Okay, this is first pass. Then we are going to have second pass. Do the same thing again. Okay, not in order, exchange. 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 This one, okay, this one is already in order, so no exchange. Okay, this is second pass. Then third pass is already order, no change. Ordered already, no change. This one, change. This one, change. All right. Okay, this is third pass. Then you have fourth pass. Ordered already. This one not ordered, change. This one not already ordered. Okay. And then last pass, this one ordered, then settled. Okay. So this is bubble sort. Bubble sort, the complexity is n squared. That means you have many pass and many iteration. Okay. Now let's have a look at another kind of sorting. This is selection sort. Selection sort means you have first pass, you check which one is the minimum, and then you exchange with the first one. Okay, and then from here, check which one is the minimum, then exchange. Then check here which one is the minimum, then exchange. All right, so let's have a look at this. Okay, this one is unsorted. Okay, we start with the first location. We find what is the minimum inside the array. Okay, so this is the first pass. Okay, we check, and then we find, okay, 2 is the minimum. So what we are going to do is we are going to exchange 2 with 7. We are going to swap this like that. Okay, so that means your first location now has been sorted. Now we start with second until the last one. Okay, so same thing. You are going to check what is the minimum. In this case, okay, we found 3 is the minimum. So we exchange with 4. And then we start with the third location, so on and so forth until everything becomes total. Okay, that is why it is called selection, because we want to select which one is the minimum. That's why we call it a selection sort. Bubble, I don't know why it is called bubble. Maybe you can try to ask ChatGPT or something like that why it is called bubble. Yeah. Other type of sorting, insertion, okay, merge sort, quick sort, keep sort. This is for you to explore. Okay, I'm not going to cover in this lecture session. Okay, so there you have it. We have covered the linear search, binary search, bubble sort, and also selection sort. Okay, the rest are basically the details, I would say. Yeah, the details. Linear search is basically sequential search. Okay, so I'm going to cover this in maybe in the online session, hopefully tomorrow. All right, so we are going to have a look at the algorithm one by one, because what you have seen is first you need to understand first. Once you understand how you can actually break down into step-by-step instruction. Remember, programming is all about putting step-by-step instruction, because computer, of course, doesn't know how to search, how to do sorting, so on and so forth. So you need to actually write codes line by line. Before you write codes, you are going to know the algorithm and then put it maybe in pseudocode or flowchart, something like that. Then you can translate that into code. Okay. So I guess that's all. If you have question, you can ask. Otherwise, we call it a day. See you tomorrow. Thank you.